Okay, so decomposition reactions. Take a look at number 1 on your problem set. NH3. This is a binary compound. There's only 2 things in it. It's binary. So what you get if you heat it, if you break the bonds using energy, right? We have to add some energy to break those things apart, the nitrogen and the hydrogens. NH3 looks like this, by the way, the Lewis structure, just so we're all on the same page. Is that what you would think it would look like? Mm-hmm. Nitrogen tends to make 3 bonds. It's got a lone pair. What's the shape of that thing? Nice, trigonal pyramidal. Very nice. All right. So, if I add enough heat, I break that thing apart. All I do is I break it into its component pieces. In this case, that's nitrogen and hydrogen. Do those exist like that, all by themselves? What do you think, Corey? How do they exist?
Would it be NH2 or would it
be H2 for sure, right? Hydrogen gas. What do you got, Ken?
N2.
And N2.
What would you do with the extra hydrogen?
Okay, so that's a great question. So there's 3 hydrogens over here, and now there's only 2 over here. So now that we form these new molecules, these are stable molecules, right? H2 exists. We're breathing it right now, actually, right? And this is like 68% of the atmosphere, nitrogen. So these are stable molecules. They exist. Now we balance it. So how many ammonias do I need to make?
2.
Exactly. So if I put 2 right here, Corey, now I've got 6 hydrogens on the left-hand side. And all I have to do is put a 3 right here. Now I'm balanced. I've got 6 hydrogens here and 6 hydrogens here. So that follows the first law of thermodynamics, right? The conservation of mass and energy. But it's important to note, I'm not going to just put H3 over here. Okay, because look, if hydrogen has 1 electron, and I put 2 of them together, that works, right? I can make a bond. Where's this next one going to go?
Nowhere.
Right? So that just can't happen. You can't have H3. So make the formula based on what's stable, what's possible, right? Then balance it after you're finished. And what this means is if you had just 1 ammonia atom, you couldn't run this reaction. It wouldn't take place. You have to have 2 of them, and then you'll get these products. So that's this is the first example I want you to remember. All you do when it's binary, when there's just 2 things, you just break it down into its component pieces. That's simple, right? So the next one, this is a little bit more complicated. So if you have a hydroxide, what's the formula for hydroxide? What do you think? Yep. OH. It's OH minus. It's a polyatomic ion. It's on your periodic table.
I was going to say HO.
Right? Well, that's not wrong. It's just dyslexic.
Right?
Yeah, that's fine. I'm dyslexic, so. Right. So if you heat hydroxide, if you apply heat, you always get water. So this is a rule I want you to write down in your notes. You can transfer it to your periodic table later or whatever. Water's liquid, obviously that's its phase. You always get water and you get an oxide. What do I mean when I say oxide? Something connected to oxygen, right? So let's say, for example, that I had calcium hydroxide. Right? I have calcium hydroxide to start off with. I'm going to get water, and then what do you think, Silas? What's the oxide if I start with calcium oxide? I mean, if I start with calcium hydroxide.
Calcium oxide.
Yeah, it's a Freudian slip. So you get calcium oxide. What if I replace this with iron? Let's say I start with iron hydroxide, and let's say it's iron 3 hydroxide. Then what do I get for an oxide? What do you think, Darren? Iron oxide, exactly. What's the correct formula for iron 3 oxide? How many oxygens would I need if it's iron 3? 3, exactly. And how many oxygens do I need if it's iron 3? How many irons do I need if oxygen is what I'm bonding to? 2, because it has a 2- oxidation state, right? It makes 2 bonds. So that's the correct oxide if you start with iron 3 hydroxide. Is that okay?
Where do you get the H2O from?
The H2O. So what we're saying is, as a rule, if you heat a hydroxide, any hydroxide, you always get water as a product. And then there'll also be an oxide. And that will change based on what metal you put in there. All right?
I got it.
Cool. The next one, the next rule is carbonates. What's the formula for carbonate? What do you think, Claire? CO3. Everybody know the charge? 2 minus. All right, so if you heat one of those, you always get the same thing. You always get CO2, which is a gas, right? We're breathing it right now. And you also get an oxide, just like the reaction above. You get an oxide. So let's say that I started with calcium carbonate. What's the oxide? Megan, what do you think? If I start with calcium carbonate, what's the oxide? Valerie, what do you think? If you start with calcium carbonate and you're going to get an oxide, what would the oxide be? Calcium oxide, exactly. Exactly right. So it'd be CaO, Megan. All right, let's say I replace that with iron. So I had iron 3 carbonate. Iron oxide, exactly. What's the formula for iron 3 oxide? How many oxygens would you need if it was iron 3? 3. And how many irons do you need if you bond to oxygen? Oxygen tends to make 2 bonds, right? So you need 2 irons. Nice. All right, so whenever you burn or heat a carbonate, you always get carbon dioxide and an oxide. Cool. The last rule is this. If you were to heat a chlorate, actually that's probably all right. So if you heat a chlorate, what's the formula for chlorate? Anybody remember? It's a tough one. ClO3. Awesome. ClO3, what's the charge? You know that? 1 minus. Awesome.
Andrew, you cheated.
He's not. No, that came out of his brain. That's amazing. All right. So if you heat that, what do you get? You always get the same things. You get O2, you get oxygen gas, and you get a chloride. The reason you get a chloride is because chlorine is more reactive than oxygen, right? You normally would get an oxide, right? But chlorine's more reactive than oxygen, so that's what you get. You get a chloride. In this case, let's say that we had calcium, let's say we had calcium chloride, or chlorate to start with. What would the oxide, what would the chloride be? Sky, what do you think? If you start with calcium chlorate, what's the chloride you're going to end up with?
Well, it would still be calcium.
It'd be calcium. Yep, so calcium chloride, right? And the formula would be CaCl2. Cl2, exactly.
Should we be like taking all these down? So
Yes, now I want you to take these 3 rules down on your periodic table. 1, 2, and 3. Put those on your periodic table. You'll use these for the test, for your competency. These ones are always the same. All right, so if you burn a chlorate, if you heat it, and you give it enough energy to break the bonds, you form oxygen gas, it'll bubble out, and you'll form a chloride. Yeah, of course. How do you feel about the back of that homework quiz?
I feel like that'll work.
Any questions on this? So what you want to do right now is take a look at your problem set, the one that says decomposition on it. It's the end of the blizzard bag, right? The last page of the blizzard bag. We're working on 6 through 20. Get these done by the end of class. You can work together, okay? Work in your groups. Get this done by the end of class and hand in your blizzard bag before you leave, okay?
Cool.
All right, go for it.